Hey, it's Mrs. Weethy back for video lesson 2 on the types of intermolecular forces, which again is review for us, but it doesn't hurt to, review so we can apply it to the new material that we're learning. Intra and intermolecular forces. We need to know the difference between the two. Intramolecular forces are those forces of attraction within molecules like covalent bonds. Intermolecular forces, on the other hand, are the attractive forces that we have between the different molecules that you have within a substance. The intermolecular forces are the attractions that hold molecules together, and they're a lot weaker than the actual bonds that you have within the molecules. The intermolecular forces influence the properties of substances such as their physical state, their melting points and boiling points, and also the ability for them to dissolve in different solvents, solubility in different solvents. So if we take a look at two water molecules here, we see the bond between the hydrogen and the oxygen are very strong, and those are our intramolecular attractions. And then we have the intermolecular attractions between the two water molecules, which are much weaker. We have three different types of intermolecular forces, and the first we're going to look at are the dipole-dipole attractions. Now, a dipole, if you remember, is opposite charges separated by a short distance, and so that would be our polar covalent bond. So dipole-dipole attractions are between polar molecules, where you have the attraction between the positive end of one molecule and the negative of another one. Let's take a look at what that would look like. So we have two acetone molecules. We have the positive carbon here, and we have the negative oxygen of an adjacent molecule. So you have the partial negative and partial positive are attracting between the two molecules. Another example would be an acetone molecule with a water molecule. So we have the positive carbon on the acetone is being attracted here to the negative oxygen on the water molecule. And it's what allows the acetone to mix with the water or to dissolve in the water. If you think of this, like dissolves like. So like are two polar or a polar with an ionic, because ionic are very strong polar molecules or formula units. So the like dissolves like is a good rule of thumb when we're looking at how two atoms or two molecules interact with one another. Non-polar, like oil, doesn't mix with water because water is polar, so unlike doesn't dissolve. Hydrogen bonds is a specific type of a dipole-dipole attraction. You have special requirements that have to be met in order for two molecules to form a hydrogen bond. And they include where you have one molecule has to have an oxygen, a nitrogen, or a fluorine atom. The other molecule has to have an oxygen atom, a nitrogen, or a fluorine that is directly bonded to a hydrogen. Okay, and then the hydrogen bond is going to occur between the oxygen, nitrogen, or fluorine in one molecule and the hydrogen of an adjacent molecule. But that hydrogen has to be bonded to an oxygen, nitrogen, or a fluorine because they're very strong electronegative atoms, and it's going to form the strongest of those intermolecular forces. And so we have an example here. You have the hydrogen of one water molecule is being attracted to the oxygen on an adjacent molecule, and that oxygen is bonded to a hydrogen. Another example we have is a water molecule with a formaldehyde. So you have the oxygen of one molecule is going to be attracted to the hydrogen of an adjacent molecule, and that hydrogen is bonded to either oxygen, fluorine, or nitrogen. Now my question to you is, can two formaldehydes, okay, and these are formaldehydes right here, can two formaldehyde molecules form a hydrogen bond between each other? So I want you to think about that, maybe copy down this diagram, put it into your chill, and then we're going to talk about this in class and see what you think. Our last are London dispersion forces, and these are forces of attraction between nonpolar molecules or free atoms. Nonpolar molecules like hydrogen molecule, free atom like noble gases, like helium. Remember that nonpolar molecules don't have permanent positive and negative ends. They don't have permanent dipoles like you have in a polar covalent bond. Instead, these molecules or these free atoms are going to form temporary dipoles or instantaneous dipoles by the constant movement of their electrons. So let's take a look at a water molecule or a hydrogen molecule. Here, completely nonpolar because the electrons are being shared equally. But as these electrons are in constant motion, in this one instant, the electrons are drawn to one hydrogen over the other, forming a temporary or an instantaneous dipole. And so now we get our partial positive and negative charges. And then they're moving around, and we have equal distribution, so nonpolar again. And then those electrons constantly moving. In this instant, it is closer to this hydrogen than the other, forming another instantaneous dipole. But what this allows these molecules to do basically is to interact with one another within their physical state, and what contributes to their melting points, boiling points, and also their solubility in substances. Okay, and this is just a general summary. If we take a look at the different kinds of substance, here we have a nonpolar molecule, you have a temporary dipole, London dispersion forces, this is the weakest, and then some examples. Polar molecules that do not have hydrogen, fluorine, hydrogen, oxygen, or hydrogen, nitrogen bonds, they have permanent dipoles, but they form the dipole-dipole interactions. Their relative strength is intermediate. And then we have polar molecules that do have hydrogen, fluorine, hydrogen, oxygen, and hydrogen, nitrogen bonds. They have permanent dipoles. They form the hydrogen bonding, which is the strongest of the intermolecular forces. And with that, that's the end of our video lesson 2. And so I will leave you with this. Well, my little video doesn't want to work, but we're going to be happy, have fun, and dance.